All right, welcome. This is a random question from calculus. So this is a limit as x approaches 4 pi over 3 of sine of x over x. Now this was an interesting problem because it appears to be one of the special forms, right? We had this whole argument for sine of x over x, but that only applied when we had x approaches 0. Let's remember what that special form looked like. When sine of x over x approached x equals 0, we could not use our method where we plugged in the value because sine of 0 was equal to 0 and x equals 0. So we get this weird indeterminate form, and we had to use a different approach when we evaluated this limit as it approached x equals 0. We do not have that problem when x equals, or when x approaches 4 pi over 3. So let's take the same limit but approach x equals 4 pi over 3 and see if we can use the plug-in method. So we'll need to find what sine of 4 pi over 3 is, and we'll divide that by 4 pi over 3. So let's see, I'm thinking about my unit circle here. So we've got our 3 points, 4 pi over 3. So the interesting part, if you don't remember this, you can look up a better unit circle. Everything is over 2 in the unit circle, at least for our standard angles that we're looking at. You got 1 square root of 2 square root of 3, and then 1 square root of 2 square root of 3. That's how I remember my points on the unit circle. And the point I'm looking for, 4 pi over 3, I know is in the third quadrant, but it would be equivalent to, let's see, so this would be 1/3, 2/3, and then 3/3 and 4/3. So that would be this point, but in the third quadrant. So if I want the sine of that, then I want the negative y value there. So sine of 4 pi over 3 is negative square root of 3 over 2. You can also just ask your calculator as well. So that's square root of 3 over 2 divided by 4 pi over 3, but I'm going to show that as multiply times 3 over 4 pi to make that a little easier on me. Now, when I multiply these things, that gives me a final value of negative 3 square root of 3 divided by 8 pi. Hey, there we go. And there's the limit. No special form for sines, cosines, or tangents is required because this limit is not one of my special forms. Sounds good.